So now adding on to from the previous video of finding the centroid of specific areas, now we're gonna go over how to find the centroid of composite areas. And what essentially that means is if we have some object or a structure with a cross-sectional area that can be composed of simpler geometries, then we're gonna learn how to solve the centroid of most of those multiple areas. So let's go straight into an example. So let's say we have this structure or this beam with this specific geometry. The cross-section area would be this area of the beam. So this would be considered the cross-sectional area. So what would be the centroid of this beam? One thing to notice is this is actually constructed of multiple areas. So when you have a specific geometry and you realize that it's actually composed of smaller, more simpler geometries, then we actually split this up. So we see this composite area is made up of multiple rectangles, and this is how we're gonna be using what we know with respect to the simpler geometries of the centroids of these rectangles to find the ultimately the centroid of this structure here. So here are the rest of the dimensions of this beam here, and the problem statement is locate the centroid y bar of the channel's cross-sectional area. So we see that the centroid is located somewhere along this point here, point C. This is the centroid. One thing to keep in mind is the centroid of an area does not have to be within that object itself. So we're supposed to solve for this y bar here. So remember the previous equations that we used to solve for the centroid of areas. Now in this case, since we know the areas of these simpler geometries, which are just rectangles, which is length times width, instead of integrating, we already know the formula for the areas here, so these equations actually simplify further. So for the x bar is the sum of the xi, which is the centroid with respect to each of its composite areas, times that specific area of the of that smaller, simpler geometry divided by the sum of all the areas. And the same is with the y bar. So here are the equations to solving these the centroids when it comes to these simpler geometries, squares, rectangles, triangles, and so forth. So let's go ahead and just number each composite area. So this rectangle will be rectangle number 1, this would be number 2, this would be number 3. So now since we see the centroid, the reference point of y bar is with respect to the top portion of this body itself. So this is where we're going to be basing off all of our calculations with respect to the top portion of this. So for the composite area number 1, the centroid or the y bar of this specific area will be right at the center. So we see this rectangle has a length of 6 inches, so it's actually going to be 3 inches with respect to the top, right? So 3 inches, this is our um, y bar for this specific area here. So it's going to be 3 inches times the area of this one. So area is 6 inches times 2 inches here. So 6 times 2, 12-inch squared. So that's for area number 1. So now we add area number 2 here. So we see the centroid of this rectangle is going to be here. We see that the height of this rectangle is 2 inches, so it's going to be 1 inch from the top portion here. So 1 inch, that will be our y bar here, times the cross-sectional area of this rectangle. So it's going to be 12 inches times 2 inches. So it's going to be 24-inch squared. Plus the third area is going to be basically the same as area number 1 because they're the same. So it's going to be 3 inches from the top. So here's the center of that rectangle. It's going to be 3 inches here times the cross-sectional area, which is 2 inches times 6, 12" squared. Then divide that by the sum of all the areas. So the area, the cross-sectional area of the first rectangle is 12" squared. 12" squared plus the cross-sectional area of number 2 is 24" squared plus another 12" squared. Just calculate that and we get our y bar being equal to 2 inches. And this is the y bar that we solved for the centroid. So this is where the centroid is located with respect to the y-axis here of this composite area. And so this is how you solve the centroid of composite areas. So whenever you have a structure or cross-sectional area that you could tell is composed of multiple or simpler geometries, you're actually able to use these simplified formulas. Instead of using integrals, you just use the sum of the centroids of each specific simpler geometry times that area divided by the sum of areas. Now, one thing by inspection, when it comes to the centroid with respect to the x-axis, here we see since it's symmetric, the centroid is going to actually be the x bar equal to 0 with respect to this axis here. You could tell just by the geometry since it's symmetric. Now you could go ahead and do the calculations for the x bar and just test that out. The more you do this, the more better intuition you have of this, but it all comes with practice.